Welcome to CS288, Module 9, our final module in the 288 Network Administration class. This time we're going to be talking about chapters 10 and 11, Securing Windows Server and Managing and Monitoring. Our objectives are going to be to discuss manage security in Windows Server 2008 with various Windows utilities, discuss threats to Internet Protocol security, create an Internet Protocol security policy, discuss network access protection a little bit more in detail. We touched on that in the previous module, and install network access protection. Tools for managing network security: Security Configuration Wizard, Windows Firewall, Encrypting, File System, BitLocker, and MBSA. Security Configuration Wizard provides step-by-step wizard for hardening your network servers. Security policies can be created for role-based service configuration, network security, registry settings, and audit policy. So the Security Configuration Wizard is a great wizard, great way of hardening your network servers. Sometimes when you set this up, you harden it a little too much, and then you no longer have access to what you want. So you may have to run it several times in order to get it to go exactly the way you want it to go. Windows Firewall, built into all versions of Windows nowadays. It allows users to turn the firewall off or on. By default, of course, it is turned on and allows exceptions for programs and ports. When you install a new program or a new role, service role, that kind of thing, or feature, it is supposed to open up a firewall port to allow that service to work. However, it doesn't always do that, and sometimes you have to go into the firewall to go turn something on to allow the traffic through. Allows you to create what's called exceptions for inbound traffic. Exception: instruction to open a port briefly, allow a program or service to pass information, and then close the port. That would be an exception. So here's a picture of our Windows Firewall, and you can see it is turned on by default. From here we see the Windows Firewall settings. You can see in Control Panel under Firewall. And you can see on, block all incoming connections. Of course, that's not all that useful if you want to get access to some of the resources that are on that device. So you got to make some changes. And you can make those changes to the Windows Firewall with Advanced Security. It provides a more robust interface for managing the firewall policies in detail, and it's used to manage Windows Firewall based on port, services, applications, and protocols. So lots of different ways you can open up a port. Here we see the inbound rules, the outbound rules, connection security rules, that kind of thing. So you can go into the Windows Firewall and you can add exceptions to various different ports. As I mentioned, inbound rules, outbound rules, connection security rules, and monitoring can be done on the advanced firewall. Windows Server 2008 uses the following network profiles. So when you first connect a network connection, you get an IP address, and a box will pop up, and it will say, hey, what is this going to be used for? Is it going to be a public connection, where say you're out at Starbucks, or is it a private connection, say at your home? Or is it a domain connection, which would be at your office where you're using Active Directory? You never want to choose public, because public locks down a lot of ports and then makes it very difficult to use once you move from a public place into a private or domain area. Now, if you have a computer that's always going to be public, that's fine. Go ahead and choose it. But if you're going to be moving around from public to private to domain, then you want to choose the one that gives you the most amount of open ports so you can do your work, which would be domain or private. Either one of those would be fine. They're very similar in the way they're set up. Deploying Windows Firewall settings via group policy. You can also say, hey, when somebody connects into the network, they will get these particular group policy settings. Encrypting file services. This allows the encryption of files and folders. It doesn't encrypt the entire hard drive. It just encrypts files and folders of your choice. Uses symmetric encryption, uses a single key, and is faster and more efficient than public key encryption. Public key is asymmetric encryption. Each user has a public key available to everyone, and a private key is only known to the user. This is more secure. EFS in Windows Server 2008, when a user encrypts a file, a symmetric file encryption key is generated that EFS uses to encrypt the file. The symmetric key is encrypted with the user's public key and stored as part of the file. BitLocker. Now this is a little different. BitLocker will encrypt the entire hard drive, where EFS would just encrypt specific files and folders, and BitLocker will encrypt the whole drive. Drive-based encryption on Windows computers encrypts entire Windows system volume of a computer running Windows Server 2008. So you can encrypt a single volume or all the volumes that are running on your computer. It is designed to enhance protection against data theft or exposure on computers that are lost or stolen. So if you have BitLocker running on your computer and it gets lost, then due to privacy policies, normally you would have to let every customer know whose sensitive data you might have on that device. But if it's encrypted, then you do not have to let them know, or in most cases, but in some states you still have to let them know, but you can tell them that it was encrypted and they are probably safe. 4 authentication modes are used by BitLocker. You've got BitLocker with a TPM, that's a Trusted Platform Module. This is a special hardened chip on most laptops and desktops and servers nowadays. So if the hard drive ever gets separated from the module that's built into the motherboard, then the hard drive becomes unusable. BitLocker with USB flash drives in place of the TPM, so the USB flash drive does the work that the TPM would have done. It's not as fast, but it is also a way to add security to BitLocker. BitLocker with TPM and a PIN. You can also, instead of a PIN, you could use a fingerprint or something like that. So this adds an additional layer of security to the Trusted Platform Module. And you can also use the TPM and a flash drive together, so give you maximum amount of protection. Installing BitLocker, hard drive needs to be configured before installing. So before you put your Windows operating system on there, and then you got to think about how you're going to do this, because BitLocker requires at least 1.5 gigabytes of unallocated or available drive space. It needs additional space to run. System volume is responsible for maintaining the unencrypted boot information. So there's a little bit of unencrypted information that's on the boot drive, and that is required in order to boot Windows up properly. The boot volume will contain the operating system files and be encrypted by BitLocker. So everything's going to be encrypted except the tiny little boot information in order to get Windows to start up. Let's move on now to the Microsoft Baseline Security Analyzer. It is an excellent tool for performing an initial analysis of your current security setup. When MBSA scans a computer, it creates a report that is organized into several areas: security assessment, security update, Windows scans, IIS, SQL to see if your web server pages may be at risk, SQL Server scans, and desktop application and scan results. So basically all the Security Analyzer does is it goes in and it looks for vulnerabilities. Scanning a computer with MBSA, you can perform several scans, GUI-based tool, or you can run a command line. You do need to have internet connectivity in order for the MBSA to work, because it gets a lot of its information from Microsoft to see if something is vulnerable or not, because things change so quickly. The MBSA, being a static program, is not going to be very useful unless it can connect to Microsoft for the latest up-to-date information. Internet Protocol Security, an open standards framework for security network communications. It's also called IPSec. IPSec meets 3 basic goals: authentication, integrity, and confidentiality. IPSec Threats. Depending on the configuration of IPSec, it provides protection from the following threats: data tampering, denial of service, identity spoofing, man-in-the-middle attacks, repudiation, and network traffic sniffing. So if anybody is trying to gain access to your data as it's being transmitted, IPSec can protect you against these types of threats. Because if they get the data without having the public or private key, they're not going to be able to read what the data actually is. So that's how it protects against all these different types of threats. How it works. IPSec modes of operation. It has transparent mode and it has tunnel mode. A couple of different ways. Transparent mode is a little bit easier to get through some firewalls. Tunnel mode is more secure but a little slower. So it just depends on the type of connection you're trying to make based on what kind of firewall you're behind. So there's a few different ways you can use IPSec. You can use it as a site-to-site VPN tunnel. You can use it as a client to client, one computer to another computer, or you can do a client to site, so one computer to a network, such as we went over in the VPN point-to-point tunneling protocol, or SSTP type of setup. This would be more like the L2TP, layer 2 TP that we talked about, that uses IPSec and IKE together. So, for example, you've got the site gateway on one side. This would be a client to site. I'm sorry, this would be a site to site scenario, where you've got a network on one side, a network on the other, and the IPsec between them. So, if you are in a 192.168.0 and the other office is 192.168.1, you'll be able to communicate back and forth with each other as if you were in the same office, which can be very handy when your offices are separated by many miles. Another scenario would be a client to site. So your client would have a VPN client on it, such as a Windows VPN client or some other third-party product, and it would connect to a gateway device, such as a Windows Server 2008 with VPN services installed on it through routing and remote access. And from there, the client computer can access all of the server resources once the gateway device authenticates. IPsec security association modes. The IPsec uses the IKE, or Internet Key Exchange, to negotiate security protocols. IKE generates the encryption and authentication keys used by IPsec. So IPsec is encrypted, and it gets encrypted because of IKE's ability to create these authentication keys. So there's two different phases to an IPsec connection. One is the main mode, or phase 1, and the other is the quick mode, or phase 2. IPsec uses two security services, encapsulating security payload and authentication headers. So you can either use ESP or AH. You would not use them both. IPsec policies can be managed with the following tools: WFAS, IP Security Policy Snap-in, NetSH, which we talked about earlier, or GPME. So there's various different policies you can use for managing. All right, so we look at a graphic here. We've got an IP header. This is basically a packet involved here. So on the left-hand side, of an IP header, an ESP header, and then you've got the payload on the inside, and then when it transmits, it ends up with the ESP trailer and the ESP auth trailer. So that is one way of the encryption, encrypted with the ESP header. And you have ESP in tunnel mode, which also gives the IP header, ESP header, and the payload, etc. So they're also signed by the ESP auth trailer in both of those cases. So this is ESP used in tunnel and transparent mode, the two different modes that we talked about earlier. Now we've got AH in tunnel and transparent mode. This looks a lot different. You have the IP header, authentication header, then you've got the payload, then you've got on the AH and transparent mode, the IP header, authentication header, and then the payload. So with AH in tunnel mode, you do have that extra IP header information that shows up. With transport mode, you do not have that. Network authentication in Windows Server 2008 supports the following authentication protocols to some degree. You've got the LAN manager, NTLM1, NTLM2. All forms of NTLM use the challenge response protocol. Now, we talked about this in the last module, the network access protection. It can be broken into three parts. You've got the policy validation, the policy compliance, and the access limitation. So the validation first is when you connect to the computer, and it validates whether the computer is going to be able to pass that traffic by looking at the next phase, which is compliance. Compliance is based on which boxes you check that say such different things as, do you have an antivirus client installed and is it up to date? Do you have your Windows updates installed? That kind of thing. And then once it determines that information, if it doesn't meet everything, it gives you a limited amount of access. And what it does, it sends you over to a compliance server. Now that compliance server, if you allow it to, it will get you into compliance so you can then connect to the network. So you have the enforcement client, you have the enforcement server, host credentials authorization protocol, health registration authority, the network policy server, remediation servers, that server that you're sent over to remediate any things that you are not compliant with, the system health agent and the system health validator. These are all the different parts of the NAP technology that makes that work. So the NAP enforcement methods include the 5 types of NAP enforcement methods. You've got the 802.1x authenticated connections. You have DHCP, so you can get an IP address on the network. IPSec, so you can have secure communications. Terminal services, another NAP enforcement location to see if before it lets you onto a terminal server. Virtual private network. So all these different ways into your network, you can use NAP to enforce whether or not those people will be allowed into your network. NAP was designed by Microsoft to allow you to customize it to meet unique needs of your network. Implementing and configuring NAP differs from network to network based on requirements and policies. So if you're using a site-to-site or type of VPN tunnel, then it differs from that type of connection. Now, Microsoft wasn't the first to develop a network access protection. I have seen it from Cisco for many years prior to that, and there's some other third-party products. But when Microsoft created their own type of network access protection, they included it in Windows Server 2008, which makes those third-party products no longer necessary. But most of the third-party products that I've seen out there do allow for far more customization than the Windows NAP has included. So you can drill down even further to what they can and can't do based on the health of their computer, and even run an antivirus scan on that computer before it lets you through. Again, only on the third-party ones. So if we look at an example of NAP deployment, we have our remote client. It goes to the DMZ perimeter network, hits the VPN server, and from there it goes through a series of checks: health registration, DHCP server, health policy server. Maybe if you're accessing through wireless, there's that as well, and of course Active Directory domain services. So if it fails in your network policies, then it gets sent over to this restricted network where a remediation server will take over and try to get you up to compliance before letting you back into the regular network so you can get access to all of the resources you need. So installing NAP. NAP is part of the NPS role. To install NAP components, add the NPS role, Network Policy Service role, to either through the Role Services wizard or from a command line server manager cmd.exe. From there, you'll see the NPS role, and then underneath that, that's the role service is NAP. MMC 3.0, Microsoft Management Console, provides a framework for tools referred to as snap-ins. You use snap-ins to manage and monitor all your servers in your network from one location. You can run MMC from any command prompt to start. So if we just go ahead and type MMC, we can see that the Management Console starts up. And from here, you can add all the snap-ins that you want. Add, remove snap-in. Choose a snap-in that you want. Choose which server you want it to come from. So computer management, I can manage another computer besides this one. Click OK, and then there's my computer management. So there's dozens of different snap-ins that you can use to manage your network, and you can connect to other servers and computers, so you can manage them all from one convenient location. Server Manager, that's installed by default, and you use it to manage your roles, features, and role services. Use it to also manage storage, diagnostics, and configuration. You've already used Server Manager many times during the different labs in this particular course. And you can also run Server Manager CMD, as we mentioned earlier, from any prompt to open that up. Windows Software Update Services is a role you can add. It centralizes the Windows Update service for all PCs in your network. So instead of having all your computers go out to the internet to do Windows updates, you can go to a server in your network instead. It saves a lot of bandwidth, and you can also approve updates before they're allowed onto your computers to make sure you don't have any issues with some compliance issues maybe between a program and an update that may come up now and then. Microsoft Baseline Security Analyzer. It's a tool to analyze your current security situation. Mentioned this a little bit earlier, but it provides security recommendations from Microsoft, which is why you need to have it connected to the internet. And once it detects missing updates and security holes, it gives you the options to patch those at that time as well. The event viewer allows you to view and manage events. Can use forwarded events to manage all servers from one location. You can use events to troubleshoot hardware and software issues. There are extensive new event logs in Server 2008 for hardware, software, and server functionality. So I actually went through the event viewer in a previous module, and you got to see some of the DNS events that were going on with that particular server. So in summary, we talked about lots of different things. The Security Wizard, the Windows Firewall, EFS for encrypting files and folders, BitLocker for encrypting entire hard drives, a MBSA for scanning for vulnerabilities, IPSec for communicating securely, MMC for managing snap-ins, Windows Software Update Services for centralization of your updates, automatic updates, the MBSA, and fixes and recommends security patches and updates. Went through the server manager, of course, multiple times during the course, as well as the event viewer. So that concludes our CS 288 class, and I hope you have learned a lot and enjoyed the class, and look forward to grading all of your papers.